So I know that we covered factoring once already, but the reason we're covering it again is because we're going to start dealing with and talking about rational equations. And a rational equation is going to come in the form of a fraction, because when we talk about rational numbers are talking about fractions. Rational equations are going to be equations where we can have x squared minus 36x plus 9 over x squared minus 16. We're going to have variables in the numerator and denominator of a fraction. Now, to work with these here and really see how they work, it's going to be good to be able to factor them, because if there are any like terms, because the denominator really can be rewritten as x minus 4 times x plus 4, and if the numerator has a factor of x minus 4, x plus 4, we'll need to simplify it to be able to solve it. So before we jump into this chapter, I want to go over factoring one more time, just so that we can kind of get it refreshed and get back into it, as well as not jumping straight into rational expressions or rational functions right out of the gate. So what we're going to be going over first is factoring. So we're going to go over factoring one more time. So this week, we're going to go over factoring. Today and tomorrow, we'll talk about factoring these trinomials, these 3 terms. Some will be 2 terms. And then we'll cover special factoring Thursday and Friday. And when we cover special factoring, we'll cover some of the examples we didn't talk about. Factoring by grouping, when we have more than 3 terms. We can factor by grouping, or really it's greatest common factor twice. Factoring out a greatest common factor. As well as the sum and difference of perfect cubes, and the difference of perfect squares where the x or the variable doesn't have 2, we could actually have 4. Now this first one here, b squared plus 12b plus 20. Whenever we factor, the first thing that we really need to be looking for is a greatest common factor. Because whenever we factor, we want to be looking for a greatest common factor first. Is there a like term in all 3 terms? And we look at this here, so we do have b squared, we have 12b, and we have 20. If it had a common factor of b, so b cubed, b squared, and b, we could factor out b. But here, there really isn't a like term in all 3 except for 1, but factoring out 1 really doesn't change anything. So, as we worked with this here, since it is a trinomial, our next part was 2 sets of parentheses. 2 sets of parentheses, because we're factoring it down. With 3 spaces, yes. With 3 spaces. Now the next part was our signs. If the third term is negative, y'all remember? The signs are opposite. The signs are opposite. If the third term is negative, the signs are opposite. If the third term is positive, then the signs are the same, and match the middle term. Signs are the same and they match the sign of the middle term. Okay. I decided to write that on the whiteboard so that we can actually read it a little bit easier. So when we look at this here, so we have b squared plus 12b plus 20. So the sign of the third term is positive or negative? Positive, so it's telling us that the signs are the same and they match the sign of the middle term, which is, so the sign in both of these here is going to be positive and positive. And this is really going back to the fact that this third term, or this term that's going to be going here and here, will multiply together to give us the third term. And when we multiply or distribute it out, they will add together when we multiply to give us the middle. So the only way that two numbers can multiply together and be positive and add together and be positive is if they are both positive. So that takes us through steps 1 through 3, which really brings us to step number 4, which is to find the factors of the first and third terms. Find the factors of the first and third terms. Find the factors of the first and third terms. Okay. So we look at this here. So our first term is b squared and our third term is 20. Well, what are the factors of b squared? And b. Because that's the only two terms that are going to multiply together to give us b squared. Now we do have 1 in b squared, but that really doesn't help us. Now we also need to look at the factors of 20. Well, we do have 1 times 20, 2 times 10, 4 times 5. Because 3 is not a factor of 20, so we would move on to 4. Well, 4 times 5, those two meet, because the next number after 4 would be 5, and we're done. So now we need to figure out which one we want to use, 1 and 20, 2 and 10, or 4 and 5. 2 and 10. And last but not least, step number 5 is to check. Because we always want to check. Now we don't have to solve this one here because it's not set equal to 0, we're just factoring it. But the main way that we check, got tongue-tied, is really doing the outer and the middle. We don't have to worry about multiplying b and b. We don't have to worry about doing this, well, come on. This one here, because b times b would give us b squared. But where did we get b and b? From b squared. So if we multiply it, we will get back to b squared. Now, 2 times 10 is going to give us 20. Where did we get 2 and 10? Or the factors of 20. Now, most books and a lot of places will say that we want to check. If we're going to check it, we need to multiply the whole thing out. That we need to do b times b and b times 10 and 2 times b and 2 times 10. Multiply the whole thing out to actually get back to where we started. But if we know that b times b will get us b squared because that's where we got it, and 2 times 10 will get us back to 20, there's no real reason to actually do that step. The main one that's going to change, depending on the setup, is going to be the middle term. So if we check it here, b times 10, we get 10b. And 2 times b is going to be plus 2b, which gives us, is that the middle term that we wanted? Well, yes. So this here is the factored form of this polynomial expression. Hopefully this is coming back to y'all. Any other questions on this here? All right. Let's look at the next one. A squared plus 4a minus 32. So the first thing we need to look for is to see if there's a greatest common factor between all three terms. There is not. And one of the biggest giveaways is kind of that a squared is just a squared. We don't have a number in front of it. And 32 is just a number. We don't have a variable across all three. So that's kind of a giveaway. So there's not a greatest common factor. So we're going to write our two sets of parentheses with 3 spaces. Which brings us to step number 3, our signs. So if the sign of the third term is negative, then the signs are opposite. If the sign of the third term is positive, then the signs are the same and they match the sign of the middle term. Well, here our third term is what? Negative, so our signs are opposite. One's going to be positive and one's going to be negative. Now, you might be wondering, does it matter which one we put positive and which one we put negative? Well, not really, because our last step, once we get everything plugged in, is to check. And if we check it and it does not come out to be the correct middle term, we can make adjustments. And as we found when we covered this last time with the signs being opposite, well, if the middle term, if we get the correct number but wrong sign, we can just flip the signs. We can flip them. So figuring out at this point if we got the signs put correctly really doesn't matter. We just need to put them in. Now that brings us to step number 4, finding the factors of the first and third term. Well, the factors of a squared are a and a. Now the factors of 32, well, we have 1 and 32, 2 and 16, 4 and 8. 5 does not work, 6 doesn't work, so we're done. Now we know 3 didn't work because, well, if a number is divisible by 3, then the sum of its digits is divisible by 3 also. Well, 3 plus 2 is 5, and 5 is not divisible by 3, so 3 doesn't work. 4 we see works. 5 only works if the ones place is either a 0 or a 5, so it doesn't work because it's a 2. 6 only works if 2 and 3 are both divisible by the number. Well, 2 and 3 are, 2 is, but 3 is not, so 6 doesn't work. 8 showed up on the other side, so we're done. Does that kind of make sense? Now looking at these here, which one do we want to try first? 8 and 4, 4 and 8. So which one do we want to put first? And so what made y'all want to say 8 first? Yes, I would agree with that, because since the middle term is positive, we would probably want the bigger number to be positive. And since a, the number in front of a, is both 1, so we're most likely just looking at the constant term to see which one's bigger. And our last step is to check. So we can do a times negative 4, which is negative 4a. 8 times a is going to be plus 8a, which gives us a positive 4a. Is that what we wanted? Yes. So these here are the correct factors of this here. Any questions on this so far? Now, most all the ones that we're going to do here in class are going to factor. They will be factorable. But will every single polynomial, or here quadratic, be factorable? Well, no. because we did have some, especially once we delved into quadratics and higher degree polynomials, that gave us complex solutions. We had solutions where I was in the answer. Well, those are not factorable because they don't have real components. Or we could have that x is equal to, say, the square root of 3 plus 1, or something like this here. Well, those don't have real or rational factors. So it's hard to factor it out without knowing the solutions first. We can't just go from this, if this was the answer, go from its polynomial to the factors of this. It's harder to work with. So some of these polynomials will not factor. It could be just that's as simplified as it gets, and there's one of those on the homework sheet where you just put just simplified. That is not factorable. And it could also be that the only way that we can factor it is by pulling out a greatest common factor. Does that kind of make sense? But let's look at this one here. Now, does this one here have a greatest common factor? Well, no, because we do have x squared, 17x, and 72. They don't have a number that's in common with all three that we can pull out, or a variable that is in common with all three. So we can do our two sets of parentheses with 3 spaces. Now our next step is to find the signs. So we look at the third term. Well, the third term is positive. So the signs are the same and they match the sign of the middle term. The middle term is negative. So we have negative and negative. Does this kind of make sense, Yara? Yeah, and it's most, because you weren't here when we covered this the first time, and I'll say this again, most textbooks I've not seen actually cover it in this setup or this style. There's lots of different ways to do factoring, and I've found that this is the most effective way to get at it. And the ingenuity, or kind of the genius behind this middle step with the signs, comes from the fact that, well, if I go back a page, is when we do the distributive property out, the multiplication of this term and our number, this term and our number, end up getting added together. And to get the last term, we're multiplying these two together. Well, looking at this here, for this number to be positive, well, either the two numbers here and here are both positive or both negative, and because when we do the distributive property, it'll add them together to get the middle, it kind of gives it away. And that's where that comes into play. Okay, that kind of makes sense. Now, with that being done, well, we've gotten through steps 1 through 3, which brings us to step number 4 to find the factors of the first and third term. Well, the factors of x squared are going to be x and x. And we'll look at these again tomorrow, where we'll actually have a term in front of x squared, or that first term that's not just 1. But we can still put, say, x and x, because the only way that we get x squared or a squared is, well, x times x or a times a. The variable multiplied by itself. And as I said last time, if there's only one set of terms or one set of factors, go on, just plug them in. Now 72, well, we'll have 1 and 72, 2 and 36, 3 and 24, 4, 18. 5 won't work, but we do know that 6 will. 6 and 12. 7 won't work. 8 will. 8 and 9, and we are done because, well, 8 and 9, they met. Because the number after 8 would be 9. It's already listed, so we don't have to list it again. There are a lot of numbers up here, yes? Now, we didn't mention the fact that when we have this here, the signs are the same, they're going to be added. Those middle terms will be added together. Well, with the signs being the same, well, most likely it's going to get bigger, whatever those numbers are. So which set of factors do we think probably won't work? Yeah, I'd say this one here would be one I would leave to the very end. Those numbers are way too big. Are there any others that look way too big? 6 and 12 might be, and 8 and 9. I would look at the smaller ones first, because we do have a smaller middle term. 4 and 18, because 18 is a little bit big, so we can look at 8 and 9. Now, I wouldn't straight eliminate the others, because it might work out that they could work. Not likely, but I'm going to leave them to the end. Because the only reason I'm kind of not eliminate these or kind of more straying away from them is they're a little big. They might not work. So I'm going to look at this one here first. And lastly, we can go on and check to see which ones do work. I don't know why I drew that. They're the exact ones I wasn't going to do. Because we really just need to look at, come on, 8 and 9, or x and negative 9 and negative 8 and x, these here. Because we do know that x times x will give us x squared. And negative 8 times negative 9 will give us a positive 72. So we just need to look at x times negative 9, which would be negative 9x. And negative 8 times x is negative 8x. Negative 9x minus 8x is 17x, which is exactly what we wanted. Any questions on this here? We feel pretty comfortable with this? Yes. Okay. Let's see here. Let's skip to this one here, number 8. So I think that's probably on the next page. So this one here is a little bit different. What makes this one different? There's a greatest common factor of 2. So the first thing we'll need to do is actually factor it out. So if we factor the 2 out, it'll let me write. There we go. We're pulling it out of each term, or essentially we're dividing each of the terms by 2, since that's the greatest common factor. Now 2r squared divided by 2 is going to be squared plus 3r, because 6r divided by 2 would be 3r, minus 4, because 8 divided by 2 would be 4. Now, since there's not any other greatest common factors, we can go on and set it up with 2 sets of parentheses with 3 spaces. Which takes us through steps 1 and 2. Step 3 would be the signs. So if the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is negative, so the signs would be opposite. One's going to be positive and one is going to be negative. Which brings us to step number 4, to find the factors of the first and third term. Now we're looking at r squared and 4. We're not looking at 2r squared and 8 because we factored out the 2. So the factors of r squared are r and r. And we already got enough of that over the last 2 weeks. And the factors of 4 would be 1 and 4 and 2 and 2. Which one do we want to try first? 4 and 1. And lastly, to make sure that this works, we can go on and check it. Well, I don't know. There we go. Wow. There we go. Apparently. No idea. Now, when we check this here, r times -1 would be -1r or -r. And 4 times r is going to be 4r, which gives us 3r, which is the correct middle term because we're looking back at, well, apparently I'm just going to erase that term there, which tells us this is it here. Any questions on any of this here? Do we want to look at number 9 or 12? Or do we feel comfortable with both of those? Okay. Because both of those would work in the same exact fashion. We would factor out the greatest common factor and go along the same lines as what we just did. Let's look at this one here. 3x plus x squared minus 10. Can we factor this? Most likely, yes. The kind of issue is it written in standard form? Now, if we wrote it in standard form, well, we would want to start off with our x squared plus, okay, 3x minus 10. Apparently this smartboard just does not want to do math today. A little bit. We really just needed to rearrange this one so that it's in standard form, and standard form is just saying that the variable with the biggest exponent goes first, and then in decreasing order from there. Well, that was the only real change, because from there, we can have our 2 sets of parentheses with 30 spaces. Now, since the sign of the third term is negative, our signs are going to be opposite. One is going to be positive, and the other is going to be negative. Then we need to find the factors of the first and third term. Well, here the factors of x squared are and x. Well, the factors of 10 are 1 and 10, 2 and 5. Which one would we want to use? 5 and 2. And if we check this here, x times -2 and x times 5, well, x times -2 is -2x. 5 times x is going to be plus 5x, and -2x plus 5x is positive 3x, just like we wanted. So we get this here. Any questions on any of this here? Any other questions on anything we've done thus far? We're going to stop there because this here is technically considered one of our special factors. Do y'all remember how this would factor down? Well, this here is a difference of perfect squares. So it would be p minus 6 and p plus 6. And we'll go over that more on Thursday when we deal back into difference of perfect squares. Because this is going off the fact that a squared minus b squared is equal to a plus b times a minus b. Yeah, and that would work exactly the exact same way, yes. Now, the homework that is attached to the assignment is going to be a worksheet. So for this chapter here, factoring, for all this week, you will have a worksheet for each one. And there's only going to be 3 of them because what we're covering Thursday and Friday is going to be one day. It's just going to take a little bit longer to go over some of that there and go into more detail. It may or may not actually take that long. That's just how long it's taken in years past.